Atacama Oases. It's not about what you see, it's about what you hear, so you can truly understand. Subscribe now, because the videos coming next are going to be bigger, better, and way more exciting.
Could a tiny icy moon orbiting Saturn actually be a home for life? And what are the chemical elements that are essential for it to exist? How on earth did a space probe manage to crack this cosmic mystery from over 1 billion kilometers away? Back in 2005, while the Cassini probe was on its mission around Saturn, its cameras snapped a mind-blowing shot, massive plumes of ice and water vapor blasting straight out of the south pole of a tiny icy moon named Enceladus. These weren't just some random fleeting natural phenomena, they were basically a window into an entire world hiding beneath the icy crust. How on earth did these plumes even form? These cracks, which look just like tiger stripes, slice right through the thick, icy shell to reach a massive ocean of salty liquid water hidden underneath. This global ocean, which could be up to 40 kilometers deep, is hands down one of the most intriguing environments in our entire solar system. So what exactly makes this ocean so special? The reason is that Cassini's data revealed these plumes were carrying way more than just water and vapor. The probe detected organic molecules, sulfur compounds, methane, and ammonia. These molecules are the absolute building blocks of organic chemistry, but on their own, they weren't enough. Why is that? See, life as we know it needs 6 essential chemical elements, which we call CHNOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Scientists had already confirmed the presence of 5 of these elements on Enceladus years ago, but the 6th one, phosphorus, was still playing hide-and-seek. Phosphorus is actually super rare in the universe, and it's usually locked up tight inside rocks where living things can't even touch it. Because of that, scientists honestly thought its absence was a major deal-breaker for the possibility of life on Enceladus. But then, everything changed. How did they finally crack this mystery? In 2023, after some serious deep diving into old data collected by the Cassini probe, an international team of scientists led by Frank Postberg dropped a massive bombshell. They discovered 9 icy grains blasting out from Enceladus that were absolutely loaded with sodium phosphates. That discovery? It changed the whole game. This discovery confirmed that Enceladus's ocean actually holds phosphorus in a dissolved state, basically, in the form of phosphates that living organisms could totally use right away. And get this, the concentration of phosphorus in that ocean is literally hundreds of times higher than it is in Earth's oceans. How on earth did that even happen? Laboratory experiments showed that the reactions between water and rocks at the ocean floor, combined with an abundance of carbonates, play a major role in releasing phosphorus from minerals. This basically means the ocean's chemistry itself is creating the perfect conditions for this vital element to thrive. And just like that, the full CHNOPS list is officially complete. But having all the chemical ingredients alone isn't enough. Life also needs a solid source of energy to get things moving. That's where another major discovery from Cassini comes into play. During its final deep dive into the Enceladus plume back in 2015, the probe picked up huge amounts of hydrogen gas. And this hydrogen is basically like a chemical all-you-can-eat buffet for microscopic life. If these tiny creatures are actually down there, they could totally combine that hydrogen with dissolved carbon dioxide to crank out energy in a process called methanogenesis. It's the exact same process that fuels deep-sea ecosystems right here on Earth. And the discovery of nanosilica particles in Saturn's rings, which trace back to Enceladus, was the ultimate smoking gun, proving there are hydrothermal vents deep down on the ocean floor. The temperatures in these vents are reaching at least 90 degrees Celsius. And here on Earth, these hydrothermal vents deep in the ocean floor support entire, thriving ecosystems that don't need a single ray of sunlight to survive. They're totally fueled by the chemical energy coming from hot water reacting with rocks. This strongly suggests that similar conditions could be happening way out there on Enceladus. So, Enceladus brings together the 3 essential pillars of life: liquid water, chemical energy sources, and every single one of the basic chemical building blocks. This unique combo makes it hands down the most likely spot to find life anywhere else in our solar system. What we once thought was just a boring frozen snowball has transformed into one of the most exciting worlds in the entire universe. Even though Cassini's mission wrapped up back in 2017, its incredible scientific legacy is going to keep guiding our questions and future explorations for a long, long time. So do you think we'll ever finally find the answer to the biggest question of all? Are we actually alone in this vast universe?